Hi, Professor Caps. This is our final experiment. Today we're going to talk about water bending. We're going to try to repeat this experiment. We've had a lot of fails. This experiment is really difficult to reproduce. So the reasons for that I'm thinking are because A, it's difficult to get the temperature just right and cool just in the right way in order to leave a supercool fluid versus a solid phase frozen ice. So the reason that you get a supercool fluid has to do a lot with the ways that water molecules bond together. The atoms that make up water covalently bond to each other in a polar compound, but the intermolecular forces between them are formed from an H bond. And that gives water a lot of unique properties. It has a very high boiling point because of it. It has a very relatively low melting point because of it, and it also has the ability to expand as it freezes. This is really important because we wouldn't want all the water in our lakes here in Michigan to freeze. That would kill all the fish and wildlife within the lakes. So it's an excellent property of water. The other thing that water needs in order to freeze is a nucleation point. And by that, it means that water will only build into a frozen state, A, if it's cold enough and its loosely formed hexagonal crystals can bang into each other, form that nucleation point, and then freeze. The other way that it happens is if you take if water is exposed to like a dust or an impurity in the water, or even a scratch or a rough thump to the bottle will be enough to start a crystal formation point in which all the other crystals build to form the structure lattice of ice. So we're going to go ahead and try this experiment. Had a lot of fails, like I said. I'm going to give it a try again and see how we do. I managed to get some super cool, but even just sitting here, they're already forming the ice just from setting them on the table. So going to go ahead and give it a try. And we'll see what happens. You're going to have to maybe get closer, or maybe not. I don't know. Let's find out. Yeah, I don't think that one's for. Oh, wait. Oh, it worked. It sort of worked. It's kind of working. I might be pouring it too fast. It is working this time. I'm very excited. I'm very, 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 very excited. That's so cool when it works. I wish I would have colored these. I had some other bottles that I had colored, so it was easier to see, but that works pretty cool. And you are now an ice bender. Okay, let's see if we can get the glass trick to work. And in that one, see, I think I just made that one freeze again. Yeah, a little bit. Let's see. Oh, look, it's already. Look, see, there it goes. One little wrap and it freezes. Just like that. You can see the crystal. I don't know if you can see them, but they're forming in there. Okay, so if we, instead of pouring it on the ice, which was our nucleation point for this structure, supposedly, if you stick a structure in the water and hold it just long enough, it should freeze solid around it. But I don't know, that one's not working as good. I'm gonna drop the ice cube. Alright, let's try one more time with a little bit colder water. Let's see if we can get it to work. I think I also noticed that once it's, my one already iced up. Once it starts to freeze, that's it, you're done. You can't thaw it for a minute and make it work. You can't, yeah, once it freezes, that's it. It's done. Let's see if we can get this one to work. And if we put a nucleation point in there, I don't know, it might not work. see either. It's plastic, which might be ruining my experiment part with that. Yeah, that's not gonna work. Okay. Oh, maybe a little. I got a few little crystals, but it didn't really do anything much. But yeah, that's fun. I'm glad this one worked on film because I was really starting to think that I wasn't going to get any today. All right, that's our experiment. Thanks for watching.